Algebra I 13.3c, solve quadratic equations by completing the square when a is not equal to 1. So I really want you to watch the videos 13.2b, where we talked about squaring binomials, and 13.3a and 13.3b before you watch this one, so you don't get lost or confused, because we already discussed what happens when you complete the square when a does equal 1. Now we're doing it when it's not equal to 1. All right, and there's links in this video's description, so you can go right to them and watch them real quick, okay? So when a quadratic equation has its a greater than 1 or less than 1, so in other words, not equal to 1 and not a 0, we have to make it become a 1. We have to force it. We can do this with the multiplication property of equality, which says that we can multiply or divide each side of an equation by the same amount, and we'll get an equivalent equation. So if we just want x to be by itself, and it's got a coefficient of 4, we can divide both sides of this by 4, and it's going to make x equal 3, isn't it? And we can also multiply by the reciprocal, can't we? And that would isolate the x. And that would make x equal 9 in this case, all right? So to use the method of completing the square to solve a quadratic equation, the coefficient of the leading term, a, that second degree term x squared, it must be a 1. A must be equal to 1. So here's our quadratic equation. Here's a. It's got to equal a 1. We have to have our friend, the invisible 1, in front of it. And we can make it be a 1. All we have to do is divide each term of the equation by a. We divide each term by an a. So if a is a 2, we divide each term by 2. That'll make it into our friend the invisible 1, and then we'll have x squared plus 2x plus a half equals 0. See, we set it to equal 1. We made it do it. If we've got a 3 for a coefficient, we just divide each of the terms by 3. That'll turn it into a 1. That'll be a 4x, and that'll be a 1/3. See, that's all. Just force it into it by dividing it by that first leading coefficient. See, if it were a 5, we'd divide each term by 5. All right, so here's our first equation. We've got 2x squared minus 3x minus 1 equals 0. We're going to divide each term by this 2 so that we can get the x squared to have a coefficient of 1. And what happens is it becomes a 1, then we get negative 3 halves, and then we get a half, don't we? Now we can make a 0 pair for this minus half by adding it to both sides of the equation. Now we eliminate it, and we have x squared minus 3 halves x equals a half. Now here's the fun part. We take this term right here, this minus 3 halves x, and we divide it by 2. That's the same thing as multiplying it by a half, isn't it? We're going to get a negative 3/4, and then we square it. So we divided it in half, and then we squared it. Now we've got negative 3/4 to the second power. See? What we do now is we add that negative 3/4 squared to each side of the equation. So that's negative 3/4 times negative 3/4, isn't it? That's a 9/16. So here we've added it to this side of the equation. See? It was here, and it became this. See that? So we don't write this anymore. It became that. So now we have x squared and this on this side of the equal sign, and we have a half plus that negative 3/4 squared on that side. We factor the left, we add the right. So we know that on this side it's a 9/16, and we're going to add that to the half. We can turn that into an 8/16, so we can add them with like denominators. We get 17/16. And then on this side, we have the little square root sign up there because we factored it. It's inside parentheses, see? And we can use that square root property to get rid of the parentheses and that little 2 exponent by throwing a radical sign on this side. So now we've got x minus 3/4 equals plus or minus the square root of 17/16. And we look inside of here for any perfect squares, and yeah, that 16 is a 4 times 4, isn't it? So we can rationalize this denominator. We did that in 11.5b. There'll be a link in this description to go there if you're confused. So now the radical sign is only on the numerator for the 17, because that's not a perfect square, And we've got a 4 down here. So now we've got x minus 3/4 equals plus or minus the square root of 17 divided by 4. We need to isolate the x, so because it's a minus 3/4, we're going to add 3/4 to each side of the equation, and we get that x is equal to 3/4 plus the square root of 17 divided by 4 and minus. See? We can write it in a solution set like this. Because they both have 4 as a denominator, we can just draw one big fraction line and put a 4 underneath it. See that? Now, if you're really confused, you should have watched those 3 videos before that, or maybe watch this one again, take some notes, okay? Write down exactly what I did here. You might even want to write these down if you're really confused to remind yourself how to divide each term by that first coefficient for x squared. All right, so just remember, you divide every term of the quadratic equation by the coefficient of x squared, and you force it into being a 1. Then we can do it like we did in the last video in 13.3b, okay? So our next video is going to be the quadratic formula. That's 13.4a. And again, square root property, binomial squares, rationalizing the denominator, all of that, completing the square when a does equal 1. All these links are going to be in this description. You can just click right on them, all right? For anyone who's having a lot of trouble, my advice is to go back to the videos of Chapter 12, the 12-point, 1, 2, 3, 4 videos, or to the beginning of Chapter 13 to the 13.1a videos and start watching them from there, because you must have missed something, all right? So let's talk about quadratic formulas next, and I'll see you there. Bye.